Hello, folks, and welcome to the June 11th, 2026 training webinar on Central Coast Post-Construction Requirements, a Compliance Overview. Thank you so much for joining us today. This session is hosted by Monterey C, also known as the Monterey Regional Stormwater Management Program, affectionately called Mr. SWIMP, which is comprised of the cities of Carmel by the Sea, Delray Oaks, Monterey, Pacific Grove, Sand City, and Seaside, as well as the County of Monterey. The group works collaboratively to manage stormwater quality across these jurisdictions and coordinates regional efforts to address pollution entering storm drains. Our webinar today will give an overview of post-construction stormwater requirements for municipal and private projects using the 2024 San Luis Obispo County Post-Construction Stormwater Guidebook as a practical design reference. Topics will include how designers and reviewing agencies can use the guidebook to clarify Central Coast post-construction compliance expectations and streamline the design and plan review process. While developed by SLO County, the guidebook is broadly applicable throughout the Central Coast. The format of this webinar will be a 40-minute presentation followed by a question and answer period. Please use the Q&A feature on the webinar to submit your questions, and we will take them at the end of the presentation. Our presenter today is Valerie Huff, Senior Civil Engineer with Wallace Group. Valerie is a local leader in the area of stormwater quality and post-construction compliance and specializes in analysis and design of low-impact development and flood control systems. She is passionate about stormwater quality and protecting and enhancing our Central Coast waterways. Valerie holds a master's degree in water resources engineering and has over 20 years of consulting experience. Take it away, Valerie.
Thank you so much for that introduction, and just want to confirm that you are now seeing my screen for the presentation.
Yes, we are.
Great, thank you. So we are talking about the Central Coast post-construction stormwater requirements today. Excuse me while I get this keyboard queued up. And as described, the focus today is the County of San Luis Obispo Post-Construction Stormwater Guidebook. This guidebook was developed and adopted by the county. It became effective in May of last year, and Wallace Group supported the county in preparing this guidebook. And I have to give a shout out to Ann Fletcher, who's the SLO County Stormwater Coordinator. She led the effort in this guidebook, and really her vision is that the guidebook could be a resource region-wide. And so this is exciting for me to be hosting this webinar up in the Monterey area and sharing the guidebook, because that is really part of the vision she had from the very beginning. And today, again, the focus is using the guidebook as a tool for compliance with the Central Coast post-construction requirements. We'll be going through performance requirements, a brief overview. We'll talk about different stormwater control measure types. We'll talk specifically about subsurface stormwater control measures. We'll touch on rainwater harvest as a means of PCR compliance, percolation and infiltration testing, runoff coefficients for pervious surfaces. We'll go through some other resources in the guidebook, including forms, templates, and example projects. And then we'll be spending about 15 minutes towards the end on Q&A. As questions come up, please type them into the Q&A feature, and then we'll be reading through those at the end of the presentation. So we'll be holding questions to the end. I want to start by framing up our conversation just with the three documents that I'll be referencing today. So the first is the Central Coast Post-Construction Requirements, or PCRs. These were developed by our Region 3 Regional Board, and this is the regulation. Next is the Monterey Regional Stormwater Management Program, or Mr. SWIMP, Stormwater Technical Guide. And this is the effective technical guide for the Monterey region. And I really just want to clarify that the PCRs have not changed. The Mr. SWIMP Technical Guide has not changed. What I am presenting today is maybe some new information that's in the SLO County Guidebook that is intended to be a reference, but it does not modify the regulations and does not modify the requirements of the Stormwater Technical Guide. And also just talking about the hierarchy of how the PCRs are implemented through our region. So the regional board developed the PCRs, but then they delegate the implementation of those PCRs to the municipalities. So it's up to the municipalities to confirm that all of the projects that are developed in their area conform to the PCRs. And so municipalities have developed varying guidebooks as a means of just helping with the implementation and giving some guidance to the development community, who is then going out and designing and constructing stormwater features. In addition to the PCRs, it's important to always recognize that there's other stormwater requirements that we won't necessarily be discussing today. And this table just gives an overview of various stormwater requirements that may apply to your project. So the statewide construction general permit would apply to your project if it disturbs more than 1 acre. And then that central column references the post-construction requirements. And it's important to note that you may have local flood control requirements that could be for storms larger than what's regulated by the PCRs. And in that case, you may have multiple submittals related to stormwater, one for post-construction requirement and one for flood control. Now we'll do a brief overview of the performance requirements within the post-construction requirements. There are 4 different tiers of performance requirements within the PCRs, and they are dependent on the amount of new and replaced impervious square footage that you are developing on your project site. For many of you, this may be information that you've worked with over the past 13 plus years of implementation. And so I'm going to go really briefly through this. If you do have questions, again, I'll get back to them towards the end. Tier 1 is site design runoff reduction. Tier 2 is water quality treatment. Tier 3 is retention. And Tier 4 is peak flow management. And for the purpose of thresholds for PCRs where you fall in these categories, there's 2 different classifications that are defined in the PCRs. One is a single family home, meaning 1 single family residence, and then everything else falls into the second category. And the intention here is that the regional board didn't wanted to capture anything that was considered a common plan of development, meaning that if you are constructing 3 or 4 multifamily homes under a single construction permit, that would be under the everything else category, and the 1 single family home is very literally 1 home. An overview of the typical submittals for post-construction requirements, and these submittals may vary depending on the complexity of your project and also where you fall within the planning and permitting process. A typical project would start with a preliminary stormwater control plan, and this may be where you're applying for a land use permit. And here you just need to show conceptually that you can achieve compliance on your project site. Then as you move into final engineering design and construction documents, that's when you would prepare a final stormwater control plan. And now you may also be required to submit a drainage report and typically a geotech report to support those that stormwater design. Here you also be drafting an operations and maintenance plan, and then moving on into construction, where you do have specific, as an engineer of record, you would have specific inspections to document that construction. Now, following construction, you would finalize your O&M plan, which would be based on record drawings, and then finalizing a maintenance agreement for the maintenance of your stormwater control measures in perpetuity. And one thing I want to mention for this slide, and really everything that I'm describing here, is really you want to confirm submittals with the specific permitting authority that you're working within. So check with your municipality to confirm what they're expecting so that you are submitting what is required for your project. Next, I'm going to be walking through a few specific references in the guidebook that apply to various performance requirements. And again, these are all regulations that come directly from the PCRs. These have not changed, but the intention of the guidebook was to provide clarity and provide resources on how you could respond to these requirements. One of those is source control BMPs, and the PCRs require that your stormwater control plan outline the source control BMPs for all projects that are PR2 and above. And there's various types of source control BMPs. They can be structural, such as covering for a trash area, or they can be operational, meaning that you're street sweeping, you're providing training for staff. And what the guidebook does, and also what the technical guide, the Mr. Swimp technical guide does, is it provides these source control BMPs in a checklist format. And the intention is that for most projects, any of the BMPs that you will need are provided in a template and a table, and then it's up to you as the applicant to then go through and edit that table to confirm that you're covering everything that's applicable to your project. Moving on to opportunities and constraints. So the PCRs explicitly require that all projects PR3 and above prepare what is called an opportunities and constraints analysis. And the intention here is to look at different features on your site, different characteristics of your site, and identify where you could integrate passive stormwater measures into your site design. And the PCRs, I'll say, are very prescriptive in terms of what needs to be required. And this is one area that we've seen in the past where applicants have provided kind of varying levels of looking at all these different criteria. And so what the guidebook does is it streamlines all of this into a single section of the guidebook. And then in addition, the guidebook contains a checklist that includes all of the opportunities and constraints that are required by the PCRs. And this is now integrated into the SLO County Stormwater Control Plan template. And the intention, again, is that you're covering all the categories in a checklist format. So rather than having to develop this information for each project, you can go through and check the boxes that are applicable, and then add descriptions, to better describe your project or to justify why they are not applicable. The guidebook also contains guidance on drainage management areas, and this has been, I'll say, a little bit of a gray area in terms of PCR compliance. What is exactly a DMA relative to a watershed or a subwatershed? And this guidance in this table that's in the guidebook came from some guidance that was published by the regional board subsequent to the PCRs, and also just project experience in terms of seeing the types of projects that have been coming through the county over the past 10 years. One thing I haven't noted is that on each of these slides, these are little snips from the guidebook. I'm not intending that we're going through each of these snips in detail for the sake of time, but I am identifying on the slides where you can find this information in the guidebook. So the intention is really to plant the seed with you that this is a reference and that you could then go back to the guidebook and find this information if it's applicable for your project and read it in more detail. And then wrapping up the performance requirements, again, just a reminder that if you have local flood control requirements that apply to your project, you typically will need to prepare a separate drainage report. So oftentimes what we see is a drainage report combined with a stormwater control plan. And in that case, it can be really challenging for the municipality to confirm that you've met all the requirements of the PCRs. So a reminder that the regional board implemented delegated implementation of the PCRs to the municipalities, and it's up to them to confirm that indeed you have met all of these requirements. So for the sake of showing compliance with PCRs, it really is more straightforward if you can break out flood control into a separate drainage report, and often that is what will be required by the permitting agency. So for PR3 and above, PR4 and above, typically what you will need to do is document compliance with PR4, which is the 2 through 10-year storm in your stormwater control plan. And then if you need to manage, say, the 25, 50, or 100-year, that would be documented in a separate drainage report. Now we're going to jump into discussion of pervious surfaces and runoff coefficients. And I'll say from my perspective as a designer, this has been one of the more challenging aspects of compliance with the PCRs. What is in the PCRs is an equation to calculate what's called a runoff coefficient. And this runoff coefficient is different than other coefficients we would use in hydrology, such as a rational C or a curve number. This runoff coefficient is specific for small storms, and it's based on the percent impervious of your project site. Fairly straightforward equation. What becomes more challenging is understanding what is considered impervious and what is not. And if you have a surface that is maybe semi-pervious, right? It's not a lawn, but it's not a parking lot. So what is it? This runoff coefficient C is then used to calculate your retention volume. So it's a direct input to how you will comply with PR2 or PR3. What the guidebook now includes is recommendations for C values, so runoff coefficient values for commonly used surfaces. And the intention is that in lieu of calculating a C value based on percent impervious, for these types of surfaces, you can use this C value directly from the table. And this table was prepared with the intention of clarifying what the County of San Luis Obispo specifically identifies as impervious surfaces, and also what they would expect a reasonable coefficient to be if you have something that's semi-pervious, such as a DG walkway. There's a couple sections that I want to point out in this table, and specifically a big change that applies currently within San Luis Obispo County is that Class 2 ag base is considered an impervious surface. And this is based on direct feedback from the regional board as they were reviewing this guidebook. And it's also based on kind of the direction statewide that the State Water Board is taking in what they're classifying as gravel surfaces. So this classification applies to any type of gravel surface that is dense graded. And from a stormwater perspective, we are breaking out kind of two general types of rock, and that would be a dense graded versus an open graded. Dense graded means that you have a wide range of rock sizes within your mix. And so when you're compacting that gravel, the smaller rocks are filling in the voids, and you end up with a fairly dense structural section with a low void ratio. As opposed to an open graded mix, which is typically comprised of similar size rock. It's intended to be compacted, but you don't have the smaller aggregate to fill in the voids. So what you end up with is a compacted surface that can have a much higher void ratio than a dense graded surface. And this is the primary difference in how the SLO County Guidebook defines the runoff coefficient for these two surfaces. So while SLO County recognized that the regional board really wanted this incorporation, that Class 2 ag base and similar dense graded rock is now considered impervious, SLO County also really wanted to identify that there are opportunities to continue to use rock and gravel as a pervious surface for stormwater compliance. And the big difference is the rock gradation, and that's important to understand as a designer. Looking a little bit closely at the table, there's a category that we've classified as engineered pervious surfaces. And the intention here is that these surfaces are designed specifically to retain your storm, whether that be the 85th or the 95th percentile storm. And these surfaces have a corresponding runoff coefficient of 0, meaning that for those design storms, you would expect 0 runoff. And the important thing to understand is that if your rainfall depth, say, is 2 inches, that you have enough pore space within that depth of aggregate to hold that 2 inches of rain. Another challenging factor that I just wanted to point out is that the PCRs contain a table of correction factors that are in, I believe, attachment E. They're in the SLO County Guidebook in table 11. And these correction factors are meant to be used for alternative compliance only. They are not intended for use for calculating runoff volumes. I also wanted to point out that in San Luis Obispo County specifically, with these surfaces, dense graded aggregate, decomposed granite with a binder, counting as impervious surfaces for the runoff coefficient, they also now count towards the impervious surface for your PR threshold. So if you have a long Class 2 base driveway, now that could push you into a higher PR threshold. Of importance for that, again, this is specific to SLO County. Check with your local jurisdiction to see how they are categorizing gravel. Is that if you have an existing Class 2 driveway or other, parking area on your project now, that's considered an existing impervious surface. So it's categorized as impervious for both existing and proposed conditions. Next, we're going to jump into a description of some common stormwater control measures. And one of the primary things that Anne really wanted to do in the guidebook was provide some clarity on stormwater control measure types. So through, again, the past 10 plus years of implementation, we've seen a lot of varying nomenclature in how stormwater control measures are described. Oftentimes we see, kind of confusing names like a bioretention swale. And what the county wanted to do was provide clarity on what a stormwater control measure is expected to be with a specific naming classification, and also be very clear in terms of what types of features are allowed within the county right-of-way. Again, this may vary in the Monterey area, but if you're designing a project in the right-of-way, this could be a good first start in terms of some common types of stormwater control measures that other municipalities may be willing to accept. And what the guidebook does is it provides a detailed table of really every single type of stormwater control measure that hopefully you would need to include within your project. There may be very specialized cases where something doesn't fit within these categories, but the intention is that these categories are specific, but they're broad enough to capture generally all types of stormwater control measures. And so there's a very specific name, and the intention is if you're designing one of these features, you're using the name that's shown in the table. There's a description of what these features would include. And then there's also a column that shows which performance requirements are applicable for different types of stormwater measures. And the intention again is that anybody that's plan checking your stormwater control plan or your construction documents can see this nomenclature on your plans and in your report and confirm the type of facility that it is, and also the type of operations and maintenance that will be required. This is just an example of two constructed stormwater control measures in our county that had varying names assigned to them that maybe were not very clear in terms of their intention. And again, we've seen kind of a mishmash of names like a bioretention swale or maybe a bio basin, whereas the intention with the naming is that the naming will be consistent with what you see in the built environment. So visually, you can expect what the facility might look like based on the name. And again, that also clarifies the long-term operations and maintenance requirements so that if a county inspector or if the engineer needs to do a follow-up, they can look at the name of the feature. Yes, this is a bioretention basin. It should have a flat bottom. It should have these other features, and these are the things that you need to do to maintain it. So the intention is not just to facilitate plan review and permitting, but also to carry these projects through that O&M phase in perpetuity. The guidebook also includes a table of recommended setbacks, and these setbacks are relative to features that may be on your project site or on adjacent parcels. And the intention here is to try to avoid conflicts with your neighbors, conflicts with existing utilities, conflicts with possible geologic hazards such as steep slopes or shallow groundwater. So again, these are recommended minimum requirements. There may be specific reasons why on your project site you would want to go, have a larger setback, or you may be requesting a variation. These setbacks are required in San Luis Obispo County. They may vary within other regions. There's two types of stormwater control measures that I'm going to speak to very specifically, and the first are vegetated swales. And I'm bringing up swales because what we've seen in implementation is that oftentimes swales, designers try to use swales as double duty with bioretention. And what's been done in the past is that bioretention media has been used in the flow line of a swale. A swale by nature is designed to convey runoff. It's taking runoff from one part of your site to another, and that runoff is concentrated, meaning that it's all within that shape of your swale. You know, whether it's a V swale or a trapezoid, it's all within the footprint of your swale, and it's concentrated flow. And bioretention media was not intended for use in that type of facility because it's highly susceptible to erosion. What the guidebook clarifies is that if you are designing a vegetated swale, and this is in that summary table that we looked at just 2 slides ago, you should not be using bioretention soil media. The county recommends that you use native soil or compost amended native soil. And the county includes some specific criteria for design of vegetated swales that was primarily taken from Caltrans guidance. So these are values that are commonly used in industry and have been in practice through Caltrans for many years. And here are some graphics of swales around the county. Of note is that swales, in order to provide treatment, do require a minimum coverage of 50% vegetation. It's the contact time with vegetation that provides the treatment as water is flowing through these swales. And so as a designer, it's just something to consider. It looks like maybe that swale on the top left needed some closer plant spacing in order to achieve that 50%. Cobbles certainly can be used within the flow line of a swale, but you need to be creative in terms of planting around those cobbles so that you're achieving that 50% vegetated coverage. And again, kind of what defines a swale is that a swale is treating and conveying concentrated runoff. The second type of feature that I'm talking about is similar to a swale, but performs very differently. And this is a vegetated buffer strip. And a vegetated buffer strip is literally a strip of vegetation that's adjacent to an impervious surface that collects only sheet flow, conveys only sheet flow runoff. And the typical use for a vegetated buffer strip is adjacent to roadways, adjacent to driveways, adjacent to parking lots. And the top right image from Caltrans shows how a vegetated buffer strip, in this case, it's labeled as a vegetated slope, can be used in combination with a swale or channel. And the intention here is that the runoff coming from the roadway flows through this vegetation. It's a very short length compared to a swale, but because it's sheet flow, it's also very shallow and fairly slow moving. And so you can achieve the necessary treatment in a very short distance, in most cases 10 feet. So you could have a 10-foot buffer strip adjacent to your roadway that is then conveyed to a swale. It may be a vegetated swale. Maybe it needs to be a concrete V-ditch or concrete line channel for some reason. Now you don't have to count on the channel to provide the treatment, and you've achieved treatment in a manner that is relatively easy to maintain for your roads crew. These types of facilities you can mow and go. They don't require specific types of vegetation. Kind of 2 important differences compared to swales. Buffer strips can only convey sheet flow. If you have, for example, a culvert crossing your roadway, now you're in a concentrated flow condition. And so that water would either need to be treated separately or treated before it flows into that culvert. They also require minimum 70% vegetation coverage. And this value again came from Caltrans. I'm going to move on to the following slide, which just shows the typical design criteria for a vegetated buffer strip. And that 70% cover came from field studies completed by Caltrans that identified how these buffer strips were infiltrating and treating water for a variety of soil types. So what the guidebook has done is it's taken this Caltrans criteria and it's applied it directly to storms that are required for PCR compliance, and it's providing direct design criteria in terms of the length and maximum slope of your buffer strip to achieve compliance for both PR2 and PR3. I personally think this is a really valuable tool for for post-construction compliance for roadways, especially given that Class 2 base is now considered an impervious surface. So I'll say it was really an important factor for the county to include this in the guidebook to help provide some ways of compliance for rural roads or other roads that may be constructed with a dense aggregate like Class 2. All right, moving on from surface-based stormwater control measures, the guidebook does include some specific criteria for subsurface stormwater control measures, and this is all captured in Chapter 5. And subsurface stormwater control measures can include proprietary systems such as chambers. In SLO County, there's also a standard detail in the public improvement drawings for what's called a roadside infiltrator. And it would also apply to a dry well, whether that's a proprietary dry well or a custom design. Some of the important things to know about subsurface stormwater control measures is that they, again, for any project PR3 and above, you need to be preparing the opportunities and constraints checklist we talked about. But specifically in SLO County, you need to justify why you cannot achieve your PCR compliance at grade and why you need to use a subsurface SCM on your project site. Of note is that the Monterey, the Mr. Swimp technical guide does specifically require a permanent pre-treatment upstream of any subsurface stormwater control measure, with the exception of a underground facility that's constructed for one single family home. Within SLO County specifically, the guidebook does require that a certain amount of your PCR compliance is achieved at grade, meaning that you can't do everything below ground. So there's a percentage of your volume. In this case, in SLO County, it's 30% of your runoff volume has to be managed at grade on your project. And that doesn't necessarily have to be the same water that flows into your underground chamber, but it needs to be DMA somewhere on your project site, basically showing that you're putting good faith effort into trying to achieve compliance with surface, preferably vegetated type facilities. A few more important requirements in the guidebook. Again, SLO County specifically has criteria for geotech reports and also inspection reports for long-term O&M. Statewide, there are requirements for registering underground chambers as injection wells. So a standard underground chamber system typically falls under the category of a Class 5 injection well and then has to be registered through the EPA once it's constructed. And again, that's not county specific, that's statewide, but those requirements are spelled out in more detail in the guidebook. Touch very briefly on rainwater harvesting. I personally don't see a lot of this for PCR compliance, but there is a table in the guidebook that identifies how you can use rainwater harvesting to meet the various performance requirements 1, 2, and 3. And in SLO County specifically, you can take some credit towards your flood control requirements if you are holding this runoff on your project site. I'm going to jump into percolation and infiltration testing, and this is a topic I'll say we could probably do an entire webinar on. So consider this a brief overview. The guidebook does include specific criteria for where to test on your project site, and also the number of tests that you would need to use depending upon the type of facility. It also specifies specific safety factors. And again, these are facility specific. And really the safety factors are intended to represent kind of kind of the magnitude of the impact if these facilities were to fail. So you have the lowest safety factor for a surface bioretention feature if you're doing surface infiltration, meaning that you're still above grade, but you're not using a bioretention facility. You have a slightly higher safety factor because these facilities are more likely to have reduced infiltration over time. And then if you're moving below ground, that's where you'll have the highest safety factor. Of note is that if you are using the standardized infiltration rates for hydrologic soil groups, and those are in the Mr. Swim technical guide as well, that you don't need to do testing on site, with the exception of underground chambers. For underground chambers, you need to have on-site testing to confirm the infiltration rate of your soils at the depth that you're planning that chamber system. And I'm going to talk briefly about the difference between percolation and infiltration. So infiltration is the movement of water into the soil profile. So you can imagine you have a puddle on the ground and it's absorbing into the soil. That's infiltration. Once that water is in the ground and it's moving through the soil profile, that's percolation. And the typical test that we use and what's actually posted on the regional board website is a percolation type test. So this water is already in the ground, and for the most part, it's moving horizontally through the soil profile. So in general, for most soil types, water moves faster horizontally than it would vertically. And kind of the exception is maybe dune sand, where you could expect that that water moves really quickly. Now, with the percolation type test, you typically are using a borehole, which is deep and most of the water movement is through the sidewall. So you have a significant area of sidewall compared to the small diameter hole, which represents the base of your facility. So the percolation test is primarily measuring only that horizontal movement through the soil. Now, if you compare that to a typical bioretention basin, which is what I've attempted to do on this slide, I'm using numbers to represent a bioretention basin that's 4 feet wide by 6 feet long with a 2-foot gravel depth. Now you have much more base area compared to your sidewall. So much more of that water would be moving downward into the soil profile, and it would have a more limited ability to be moving horizontally. And if you look at the numbers on the bottom, the sidewall to base ratio, a shallow type percolation test would have a ratio of 24 with this example, as opposed to maybe a more typical bioretention is between 1 and 2. So what these numbers are trying to show you is just that you have much more infiltration, water moving vertically into the soil profile as you do horizontal movement. And for this reason, the guidebook requires that you use a conversion factor that's referred to as the Porcher method. And what the Porcher method does is it just takes the geometry of your borehole and it kind of categorizes what is horizontal movement versus what is vertical movement, and it applies a reduction factor to your test results, specifically when you're using percolation type testing. In general, this equation should be applied uniformly to all different stormwater control measure types with the exemption of specifically a dry well, because a dry well very closely mimics the setup of a percolation test. If you've designed another type of facility that has a significant sidewall component, maybe it's acceptable to use your percolation type testing directly. I'll say there's some flexibility there for the designer, but in general, it's recommended to use the Porcher method to account for that difference. And last thing I'll note on for infiltration testing is that, in addition to that percolation type test, there are other surface type testings you can do, and this is showing the double ring infiltrometer. And if you are designing a vegetated at-grade facility, for some reason you don't want to use the standardized rates, this is a time when you may consider using a double ring infiltrometer because these can be used in situ. So in this example, this test is being done at the ground surface with vegetation in place. And what this does is it gives you results that are representative of a vegetated soil because the roots and the soil combined significantly increase the potential for infiltration in most soil types. The roots allow that water to penetrate into the soil profile. The plants themselves provide some evapotranspiration. There's many different factors that create a different scenario for retention on a surface-based level. Whereas if you're doing a borehole type test, you may be well below the rooting depth of your adjacent vegetation. And now you're not getting, I'll say, that benefit of the interaction between the soil and the vegetation. Now we'll spend a few minutes talking through forms and templates. And again, these are not superseding any of the templates or forms in the Mr. Swim technical guide, but they're meant to be available as a reference as you're preparing your stormwater control plans. Within the SLO County Guidebook are forms for a stormwater control plan application, which is a fillable PDF, also a stormwater control plan template, and this is available in both PDF and Word format, and also operations and maintenance forms. And these are all meant to be consistent with all of the various requirements that are outlined within the SLO County Guidebook. The guidebook also includes inspection forms in a checklist format, and these have been prepared specifically for differing types of SCMs. So there's a full list there of SCMs that are included for inspection checklists. And these were prepared such that they could be used for both the construction phase, where you have to, typically it's the engineer of record that has to certify the inspection, or for ongoing operations and maintenance. There's also a group of O&M forms, and I'm not going into these in detail, but of note is that in San Luis Obispo County, these O&M forms are used as the maintenance plan. So the county saw varying levels and degrees of material that was included in maintenance plans, sometimes completely duplicative to the stormwater control plan. And so the county has consolidated all the O&M requirements into these forms. The intention is applicants will fill out the forms and then include any necessary attachments, and that is the O&M plan. The guidebook also includes various plant tables and plant lists, and these are a reference that are meant to be used directly on your plan sheets. So if you're designing, say, a bioretention facility, you can go to a plant palette that is intended for either a coastal environment or a more inland environment. And then there's a category for residential and commercial, and you can pick a table and copy and paste this directly onto your plan sheet. And the intention here was to try to highlight plants that we've seen have good survivorship within SLO County in the Central Coast region, and really just promote the fact that you don't necessarily need an expensive or detailed landscape design. You can use these plants as a starting point. And then lastly, I'll just touch on the fact that there are example projects included in the appendix of the guidebook. So there's two projects. I believe one is residential, one is commercial, and they are a comprehensive example of everything that would need to be submitted in San Luis Obispo County. They include all the exhibits, they include all the supporting calculations and the O&M forms. And the intention here is that if this is new to you, or if you have questions on what is expected, that you can go through these example projects and hopefully glean some information on how this would apply to your own project. And this last slide is just a list of resources that I used both in preparing this webinar today, but also resources that I use in stormwater control design. And those will be available to you in the PowerPoint following the webinar. So with that, I am going to start jumping into Q&A.
Thank you so much, Valerie. So we do have a question in the Q&A, and reminder, folks, if you have any questions for Valerie, please submit them through the Q&A function and we will make sure they're addressed. Our first question, are underground SCM's chambers strictly for retention and detention, PCRs 3 and 4? Does PCR 2 need to be met prior to runoff entering the chambers?
Yeah, that is a really good question. And I'll say that I have seen varying requirements in different municipalities. So this is one that I will answer based on my experience, but I will tell you that you really need to check with the municipality that you're working within. So all chambers require pre-treatment. Absolutely. Some municipalities will allow that pre-treatment to also occur underground. For example, a CDS unit or in one of the gosh, I'm forgetting the name. Some of the proprietary systems have the initial chamber that's wrapped in filter fabric. Some municipalities allow that, some do not. In SLO County specifically, they will allow subsurface treatment ahead of the chamber, but you do have to meet this other criteria that's shown on the slide, where you have to have at least 30% of your PR2 volume treated somewhere else at grade on your project site. So in SLO County, the answer is both. In other municipalities, again, check to confirm that you can achieve PR2 with a pre-treatment chamber that's, maybe part of your larger chamber system. And I'll say there is an effort by the regional board currently to start taking feedback on the post-construction requirements to prep for potential future revisions. One of the things that I have heard through those meetings is that the regional board is thinking about requiring that treatment occur at the ground surface, not in an underground chamber. So that's potentially a future change.
Thank you. All right, we don't have any questions that have been submitted thus far. Maybe we'll give it a couple more minutes to see if folks submit those. And this recording will be posted on the Monterey C YouTube channel. And now we do have another question. Would a double ring infiltration test run at a grade equivalent to the base of the proposed bioretention basin be more directly applicable than the Porcher method calculation to convert percolation rates?
Let me get back to that slide. I'll say there really, in my mind, is no direct answer to that question. I think that the double ring infiltrometer is most representative of a facility if you can test with vegetation in place. My opinion on that double ring infiltrometer is that it better helps to capture the interaction between vegetation and soil that can benefit your design. And just one example, I have spent time during rain storms driving around and seeing how facilities are performing. What I have observed is that in similar areas of our county, in very similar soil types, basins that are vegetated are draining, and basins that are not vegetated are not draining. Vegetation, like I said, it helps loosen up the soil profile. There's interaction between the roots and the water. And so if you can use that double ring infiltrometer on a surface that's vegetated, I think that's where it's going to better represent performance. All that said, the standardized rates, the hydrologic soil group rates that are within the technical guide, within the SLO County Guidebook, are based on testing of bioretention features that occurred up in the Bay Area over a number of years. And so I, as a designer, really think that those values represent most of the conditions that we'll see. I think if you're trying to justify something that is well outside the range of those values, maybe that's when you would see the benefit of going and doing more detailed testing. But if you're designing a bioretention feature, I would recommend using the hydrologic soil group rate because I think it's going to be the most representative of long-term performance.
Wonderful, thank you. Our next question is, can you put the SEM setback slide back on screen? And the question, the subsequent question is, are structure and foundation and vehicular area setbacks noted?
Yes, so there are structural foundation. I don't know if you can see my cursor, but here under the, so this table, just to spend a little bit more time looking at it, is broken down into two different types of categories. So this first category up top are infiltration features, including dry wells, underground chambers, roadside infiltrators, and then down below you have biofiltration and vegetated swales. And the reason why these two were broken out is that the top rows represent features that have a likelihood of introducing more water into the soil profile. So that was the intention of kind of these two broader categories is, in general, are you introducing a lot of water or maybe less water? And if you're introducing more water into the soil profile, that's when you want to be more conservative with your setback. So both of these categories include a setback for buildings or walls here. And I'll say the important footnote is that really, if you're talking about an important foundation wall, you should be talking with your geotech and or your structural engineer to confirm that you have an adequate setback, because that's going to be also dependent on the depth of your footing and your soil type, your depth to seasonal groundwater, a lot of site-specific criteria. And you may have an opportunity to get closer than that if you need to, if you have specific waterproofing measures on your building.
Great, thank you. So this next question is two parts, and I can take the first part and you can take the second part if you've got input there. The first part is any insight into the reissue timeline for the phase 2 permit. So the State Water Board has stated they will release the formal draft for public comment as of July 2nd of this year. The second part of this question, are you aware of any major changes coming?
Major changes, I'm assuming, to the PCRs. Regarding the phase 2 permit specifically, really the only thing that I've heard about that draft is that it is quite different than the initial draft and that it's, I think, closer to the phase 2 permit as it stands today. Regarding major changes in PCRs, I mentioned that the regional board is considering revisions to the PCRs. The messaging that they've provided thus far is that the kind of the bones of the PCRs are not changing. None of the performance requirements are going away, that the regional board is trying to clarify some of the areas that have been more confusing, and that they're also looking to provide some more equity for multifamily homes. So currently, we talked about the thresholds applying to two buckets of projects, the one single family home and the everything else. One positive change that I am optimistic would come through is that the regional board is interested in treating multifamily, triplex or duplex in the same manner as a single family in terms of thresholds to provide some more equity in terms of those different structural types. But I would say I'm not, from what I've heard, I'm not expecting any major revisions to the PCRs, and I think the timeline for that is probably 2 years out, possibly a little bit longer.
Thank you. Those are great questions. Any other questions at this point, please submit them through the Q&A. And in addition to the posting of this recording, we will have the PowerPoint slides available online on our website as well. Well, Valerie, your thorough presentation seems to have minimized the amount of questions we've got. So we are so grateful for your presentation today, and thank you so much, folks who joined us. We really appreciate having you be a part of this.
Yes, thank you so much for the opportunity. And I just want to reiterate, I don't think I mentioned, I do have my personal email address or my office email address here on this slide. Please feel free to reach out with questions. I always appreciate bouncing ideas off other designers or hearing how things are being permitted in other municipalities. So please feel free to reach out. I'm happy to respond and just share our knowledge region-wide in PCR compliance.
Wonderful. Thanks again.